The following is a video tutorial for how to assemble your miniature model train. First here I'm just looking at some of the documentation from Project Lead the Way. Here we see an exploded view with some balloons on there for the parts that correspond with this part list above. But basically it's kind of just giving us the general idea here of how this thing is going to assemble together. And then also if you scroll to the bottom of this document, you can see a fully assembled view here of what we're looking for in the end run. So I'm going to go ahead and leave this open here. I've actually kind of memorized this assembly at this point, so I really don't need to look back at here too much. And first things first is I'm going to put down the body and assemble everything else to constrain it to the train body. Here I'd like to take a look at my fully assembled train. And you can see that if you open up every one of these parts that we've brought in, there are a number of constraints that end up being applied to each and every part. And sometimes you'll even see if two parts are actually, constrained together, you'll see one of these constraints show up underneath both of those parts, whatever they may be. So I'm just going to go ahead and do a file new here. And I'm going to create a standard inch assembly. And say create. And so like I said, the very first thing that I want to bring in is going to be my body piece. So I'm going to come up here and select place. I then have to locate that file. And you can see here I've actually done a whole bunch of these assemblies already as practice for this video tutorial and just to kind of iron out a few other questions that I had. But what I'm looking for here is going to be the train body. And here it is, train body from video happens to be the official title of my part file. I'm going to select it and then say open. It says educational version, just say yes, it's fine. And there's my part. You notice there's another one on my cursor here. If I move my cursor around the screen, that's just to allow you to place more of these train bodies. I only need one of them, so at this point I'm going to hit escape on my keyboard to get off of that place command. One of the other things that's worth noting at this point is this little icon that we have right here. And you notice you see a little image of a thumbtack. That is telling us, and if I open up the hierarchy here, that this part is actually grounded. It cannot move. It's not going anywhere. If I right click on it, you can see in the list here that it is in fact grounded. Now I can change that, and eventually when I bring in the track and everything else, I will have to change that, but for right now this is what we want. So the first part that you bring into an assembly is always going to be grounded. The next thing I'm going to bring in here is going to be the cow catcher. I'll go with that next. And it really doesn't matter what you bring in next, as long as you just keep everything in order. So I'm going to bring in the cow catcher next. And the first constraint that I'm going to put down here is going to place this cow catcher right on the front of my train. So I'm going to go to constrain, and the option that I'm going to look for here is going to be mate. So I'm going to leave the type here as mate and the solution here as mate. And what I'm looking for is if at any time you have a cylindrical part, say like how we have 3 of those on the back of the cow catcher here, or any hole for that matter, if you move your cursor around that part in the right way, you should see a center line, a dashed kind of line that goes through the center of that cylinder. Now that's what that's going to allow us to do here, is select that center line, and then if I go and look at the hole on the front of the train here, I can also find that same center line. So I will select that next, and it has now basically mated those two center lines together. So if I say apply and then cancel out here and just hit the home keys to zoom out a little bit, you'll notice that that part now rotates around that cylinder. Alright, but it's still coming off the part here, it's still rotating in another direction here. One of the things that I would like to turn on at this point is if I'm going to go over to my view tab at the top here and select degrees of freedom. Alright, so that's showing me here now that I have reduced the 3 degrees of freedom, which is what every part comes out in if it's not grounded. And with my one constraint, I've taken one of those away, and I'm going to basically keep constraining this part to this front of the train here until these degrees of freedom are gone. So next, I will jump back to assemble. I will constrain again. I'm going to leave it at mate, and at this time I'm going to do another one of the spokes here, the little pegs to the hole. I could do this left one here, or I could do the middle one. It really doesn't matter. But I'm going to do the left one, making sure I select the center line and the center line here as well. I'll then say apply. You now notice I only have 1 degree of freedom left. It's that little green arrow, and that's showing me that I can push this part backwards and forwards. So the last thing I'm going to want to do is just constrain and mate the front of this train to the back flat surface of the cow catcher. Say apply, close that window there, and now since the train body is grounded and I have fully constrained the cow catcher to the train, it too cannot move. All the degrees of freedom have been removed, and that's what we're looking for that first constraint between two parts. Next, I'll bring in the stack. So I'm going to go place again and bring in my stack piece. I'll say select it and then say open. I'm going to place one of those around there. I'm going to hit escape on my keyboard to get off of that placing command. And here you have a nice view of those 3 degrees of freedom. Basically I can go up and down, left or right, back and forth in the X, Y, or Z direction. The next thing I'm going to do here, though, to constrain this guy is I'm going to go to constrain, and I'm going to say I want to mate the bottom flat surface here in this hole. So if you need to rotate to see that a little bit better, the flat surface inside the hole to the flat surface on the bottom of the cow catcher, and say apply. So that's 1 degree of freedom. And if it's ever helpful for you to say cancel and pull off, get off that window, and actually select that part and pull it back off, this is always helpful to me just to kind of remind me, okay, what's next. Alright, so next here, this part is touching that surface, and if I look at it from the side here, that is true. I can't take it up and down anymore. It just goes left and right. So one of the next things I want to do is constrain that, and I can say, so what I'm going to do is constrain and mate the center of this piece here to the center line of our hole that we see here. Say applied. That has now removed 2 of the degrees of freedom, and basically all I have left is this ability to rotate the part around this axis that you see right here, going straight up and down. Now you actually can't see it. It is moving. It's just graphically you cannot see it. So the only real way that I know that this isn't locked down is by this degree of freedom. So to fully constrain this guy into place, what I'm going to do is I'm going to come back over to my browser list here. I'm going to open up the hierarchy underneath the stack piece and open up the origin folder here. And I have these planes. Now if I've created my part correctly, I could turn on either this plane here or this plane here. I'm going to select the YZ plane though, right click on it and select visibility to turn that on. And I'm going to use this plane to constrain to one of the flat surfaces on my train, essentially. So again, I'll go to constrain here. For this one, it's going to have to be an angle constraint. So I'm going to select angle. For the solution, just a directed angle should be fine. What you want to select then is the work plane that we've turned on, the origin plane here. So I'm going to select that, and then I will select any of the flat surfaces. I could select the flat surface here, this one here. You can even do the side. I'm going to select this flat surface here on the front. You'll see that degree of freedom has disappeared once I hit apply and cancel out of here. That can no longer be moved. You see the little do not move or the don't symbol there. Circle with a line through it. It says it's not going anywhere. So at that point, since I have that figured out, I can then go back to that work plane and deselect the visibility just to get it out of the way. Alright, the next 2 pieces that I'm going to bring in here are going to go on the back. It's going to be the hitch magnet and the hitch peg. So I'm going to go to place here. And I actually have those in a different folder. Here we have the hitch peg and the hitch magnet. So I'm going to select the magnet first, place one of those. I'll hit escape. I'll then also bring in the hitch peg. Select that, say open, place one, and hit escape to get off of that. Now that I have these two things on here, I'll go ahead and put them into position. What I'm going to do first is constrain the magnet by the center line to the center line of this hole here, and say apply. Cancel out. I always like to do this, just pull it off and see what's left. Next I can constrain the flat surface. I'm going to mate the flat surface on the back side of the train to the flat surface here on the magnet, and that'll put it flush up against there. I'll say apply. And this last constrain, which allows it to rotate, we're going to leave that one open. It's totally fine to have that. That's actually how it would operate in real life, so we're just going to leave it the way it is. And then I'm going to put this peg inside the magnet. So again, constrain. I'm going to select the center line, and you might have to zoom in from time to time just to make sure you're getting that center line again. Say apply for that. Cancel out. Move off my part. I see here that it's going to be the same thing. I'm going to constrain and mate flat surface of the magnet to the underside of the hitch peg, and say apply. So both of those parts will have 1 degree of freedom left on the back to just kind of freely rotate. Totally fine. We're going to leave it the way it is. So next brings up the more difficult part of this assembly, which is going to be bringing in the wheels, the hex peg, the linkage arms, and the linkage pegs. So first things first, I'm going to go ahead and place, and I just know that with my parts here, the linkage peg, I did not recreate that one. So as opposed to just going all over the place from folder to folder to folder, I'm going to bring in my 4 linkage pegs now and save them for later. You can do this at any point if you'd like. I'm just going to make 4 of them and kind of leave them off to the side here in a cluster. But I want to place, what I wanted to place next was my wheel. So I'm going to navigate back to my other folder and bring in my wheel part. And again, I can lay down 4 of those, so 2 on each side, and then I'll begin to constrain these into place. So I'm going to go open up constraint here. First things first, got to get those center lines lined up. So a center here to a center here, and say apply. Cancel out of there, pull this part off. I can see here that I actually want the flat surface of the wheel here to be matched up with the flat surface of the train here. So I'm going to constrain and mate the back side here to the side of the train here. So it kind of flips it around for us. I'll say apply and then cancel. And then that last degree of freedom we're going to leave open because we want this wheel to turn. So that's good just the way it is there. Next I'm going to repeat that process for the other 3 wheels. So constrain, making sure I pick the center line here to the center line on there. I will say apply. I will then mate the flat side here to the flat side here. It flips it over. I'm going to rotate to the other side here and do the exact same thing. So mate that center line to this center line. Say apply. This center line to the hole here and apply. I'm going to hit cancel real quick because I do need to kind of drag these wheels off so I can get at the back edges here to constrain this. So then constrain, it's going to be a mate constraint from the flat part of the wheel on the back to the flat side of the train and apply. And then again, train to the flat side of the wheel right there, apply and cancel. So we got our wheels put on, got them lined up properly. One of the next things I'm going to bring in is going to be the hex pegs, which will screw into and through those wheels into the threaded parts, the threaded feature that we have on our train body. So next I will go to place, find my axle peg, say open, and I'm going to place 4 of those. And it's basically just the same process again. We are going to leave 1 degree of freedom open for that axle peg to kind of rotate inside the wheel there. So again, constrain. I'm going to line up my center lines to the center lines on the wheel, which should be lined up with the hole. Say apply. I'll just go make my way around doing all the center lines here. Apply. Flip it over to the other side, and I will say center line to center line, apply, and then center line to center line, apply. Now sometimes when you bring it apart and you constrain it with center line to center line first, your pegs may or may not be facing the right direction. They might be flipped around, just kind of like how you saw with my wheels on the one side as compared to the other. Sometimes it flips it, sometimes it doesn't. So you got to be aware of what orientation your part is in after you've put on your first constraint. So now I see here, all I've done is line up center lines. So I kind of want to lock these axle pegs here flat against the wheel, just about right there. So I'm going to do first here is kind of drag these all out, flip to the other side, drag this out, and drag this out. And now I will constrain and mate flat edges to flat edges. So right underneath the axle peg here, and if I rotate, you can see there's actually a flat part on the front of the wheel, and that's the other thing that we're going to select here to get that axle peg to come flush right up against the wheel. You'll notice it doesn't pull out anymore. It does, however, rotate. It's exactly what we want. So then I'll repeat that process, flat side to flat side. Zoom in here to get this one. Back it out, rotate so I can get the bottom here. Say apply. Now I'll do the other side. Flat here to the flat underside here. Say apply. You always have to hit apply. If you don't hit apply, it won't accept the constraint that you had just entered in. So flat side there to the underside, flat side there, and apply. I'll now close that window and just zoom out again to see where I'm at. Basically almost there. All my wheels rotate independently, which is good. We will soon constrain those though so that they rotate together. The last part that I need here is going to be my linkage arms. So I'm going to go ahead and place and find my linkage arms. Here's my linkage arm here. I'm going to say open. I'll place one on this side and one on the other side. So to get these into place, what I'm going to do is constrain, and then again, center lines to the center line of the peg here. Say apply, and then I'll do the exact same thing to the other side and say apply. Alright, so I have those lined up. If I hit escape here, you'll notice that it pulls off the part. However, it does rotate with the wheels, which is what we want, so that's good. At least the two wheels on each side rotate together, sort of. We'll take a look at that in a second. So the next thing I'm going to do here is constrain the flat side right inside of here to the back side of the linkage arm itself. You'll see it kind of places that on there just perfectly. We'll say apply. And so we're going to leave that third degree on this one open, of course, so that it can rotate, just like we see like that. I'm going to flip it over to the other side. I will do the exact same thing with my other arm here. So I will constrain center line to the center line here. Say apply. Center line to the center line here. Say apply. I will cancel out and just pull that off to make it a little bit easier to visualize here, and then constrain flat side here to the back side there, and then say apply. Great, so we got the linkage arms here. Real quickly, I'm just going to go ahead and insert the pegs because they do not have any real factor in terms of what the rest of what I have to do here to make this part fully assembled and constrained the correct way. So basically the same process we've been doing all along. Center line to the center line of that hole there. And you notice it flipped my peg inside out. So I'm going to pull it out and then constrain the flat side mate to the flat side here of the peg and say apply. So just be careful if your part happens to flip around. Just cancel out of it, out of the window, pull your part out, get a better idea of where it is, and then continue on with your constraints. So again, center line here to the center line here, say apply. I'm going to cancel out. Hopefully I can grab that part and pull it out. I'll then constrain flat side to the flat side, say apply and cancel. Again, with this one, we're going to leave that third constraint open so that it all rotates pretty freely. Next, I'm just going to grab these two parts and move them to the other side. And I will then constrain these into place. So center to the center here. Sometimes you got to zoom in to get that center line to pop up. I'll say apply. I'll do the same thing to this one. And apply. And it's just kind of funny. Sometimes it'll flip it, sometimes it won't. You see this one went in backwards and this one went in the correct way. In either case, just pull them off, go back in, and we'll reconstrain our flat surfaces together. So that one here to the bottom side there, and then apply. Cancel out. So we basically have a fully assembled train here. There's just a few final tweaks that we want to put in to have this actually animate the correct way. Take a look at one of the sides of your train here. You notice that if you grab this arm, it does rotate the parts. And it seems like it's working fine. But if you grab one of the wheels here, and you kind of rotate a little bit faster and just get a little bit out of proportion, what I'm looking for here is basically a telltale of whether or not this is lined up properly. Now this one seems to be working kind of okay, but you should notice on your parts, maybe the other side I'll have a better look of illustrating this. I'm going to flip over to my back side here. Basically kind of just trying to glitch it out of proportion a tiny bit, because essentially we haven't told this linkage arm to remain parallel to the bottom of the train. I can't get it to happen right now. It does happen quite a bit though. So one of the last few constraints that we're going to do here is tell that linkage arm to remain parallel to the bottom of the train. So to do so, I'm going to go into my constraints here, and we're going to make an angle constraint. I'm going to select the first solution, a directed angle. What to do here is select the bottom of the train to the bottom of this linkage arm and say 0 degrees, apply. And I'll also do the same thing to this other side here, bottom of the train to the bottom of the linkage arm, 0 degrees, apply. Now if I cancel out, I know for a fact that those will always be parallel with the train body. The wheels will move together on each side, and so that's what we want. One of the very last things that we have to do here is actually constrain this side of the wheel system to this side. So to do that, or basically what we want is when I turn this side here, I should see the other side turning opposed to it. So what I want to do, you can kind of set this up where you have one side on the top and then one side on the bottom. It does not matter. It'll figure itself out in just a few minutes here once we put in this final constraint. But what I need to do, so I'm going to look for wheel 2 and wheel 3. This is wheel 2 here and wheel 3 here. You can see when I highlight over my part, it highlights in the list here off to the left. And so again, vice versa, wheel 2 and wheel 3. I'm going to open the hierarchy underneath that part open. I'm going to open the origin folder, and then I'm going to turn on this YZ plane. So I'm going to turn on the visibility here for the YZ plane. You'll notice that it actually turns them on for all 4 wheels because they're the same part. So the last thing I'm going to do here is constrain and flush. this work plane here to the underside of this work plane here, and you can see that once I did that, both of my linkage arms jumped to the bottom of the train. So if I move one of these, they'll actually move together, but they're in the same position, and that's not what I'm looking for. So I'm going to cancel out of here. I'm going to try this again. I want to constrain one side of the work plane to the other, essentially, is what I'm looking for here. So I'll try that again. Constrain, I'll say flush the, kind of tough to grab this here, the top half of that work plane. Looks like it only gives me that one option to go to the bottom, and that's not what I want. Let's see here. I'm going to cancel out one last time. We'll try something different. So what I need to try here is actually constrain. And as opposed to making this a flush constraint, I'm going to leave it as a mate constraint. And I'm going to rotate both sides of the train so that the linkage arms and the wheels are more or less in the same position. And then I'm going to come and select this work plane here and this work plane here. You'll see right as I selected that second work plane, it basically flipped this half of the train wheel and linkage arm assembly here to the opposite position as it is from the other side. So I'm going to go ahead and say apply and cancel out of there. And what we should see is that when I operate this side of the train, the other side rotates as well, and in fact is in the opposite position. So that is how you assemble this train. Just some of the finer things to kind of clean this up, I guess you could say here, is we're going to turn off the visibility from that plane. Should turn them off on all those there. I can also then go to view and turn off the degrees of freedom, and here is your perfectly assembled part. I hope that this video was helpful. Please feel free to like or comment